I want to thank all the people that are on the phone for participating. Please tell everybody you know. Every month, 3 new companies. You can look back, and we have online the presenters from April 16th. These will be up shortly as well. The next ones are June 18th and then July 16th, as I mentioned. So register as soon as you can, just so we know. Thank you to our sponsors and partners, obviously Team A BlueTech, but our BlueTech Cluster Alliance partners, which are in Canada, France, Ireland, Norway, Portugal, Spain, the UK, and the United States. And then we are partnered with the Brink at the University of San Diego, which is a small business development corporation, helping coach our small companies. Obviously, if somebody's interested in sponsoring this webinar series, please let us know. We are going to start doing these themed ones, which I think will make a particular interest. And then finally, again, thank you to the DG Mare Blue Invest team and for everybody that's really trying to promote BlueTech investment in the community. So our tagline is promoting sustainable science-based ocean and water industries. So we are both ocean and water as a cluster. Here are our contact details if you don't have them already. And we look forward to hearing from you. And we look forward to hearing if you know companies that you think should be featured. And what we're really looking for is companies that have unique technology, that the value proposition will be recognized in other countries, so that we're really trying to help companies go global, if you will, whether they're US companies going abroad or French companies or Peruvian companies, finding great technology companies, typically with patented technologies, but that are looking for a forum where they can help get bigger visibility. Again, this is not just related to investors, because our companies need all kinds of support. They're looking for technical partners, channel partners, etc. One of the things that we are doing is putting together a list of distributors in the United States. We started on the ocean tech side. We're also now looking on the water tech side, because a small company in another country that wants to come to the United States needs help, and vice versa. Our companies need help in other countries. So if you are working with a distributor in some country that you think is really doing a great job for you and you're willing to share that, let us know. But we've asked our partner clusters to also help us. And maybe, Ian, that's something that we can work on together, because I think finding distributors in these various countries is very important to all of our small, innovative companies. So with that, what I'd like to do is begin the presentations. We have a tendency to start furthest away because it's late in the day their time. That gives our close-in US companies time to have their coffee. Since on the West Coast, it's 8 o'clock in the morning. So we are going to start with ELWAVE from France, and then we've asked them to hand it off 20 minutes later to Hefring Marine, and then they'll hand it off to Marine Advanced Robotics. That will bring us up to 9 a.m. And then on an optional basis, you can join one of these breakout rooms, or you can move around, but the idea is that you find one that you think is particularly exciting for you, and that you will get to know them and maybe see how your technology and theirs can work together, or you can help them in some way. So what I'd like to do is hand it off, Pierre, to you with ELWAVE, a company that was referred to us by our partner in the Polymer Bretagne Atlantique. Very exciting company. And we're excited that you're going to be presenting today. And then I'll just mention that Hefring Marine is a member of our partner cluster in Norway. So we are pleased to have two of our partner clusters members presenting. So I'm going to give the screen up at this point. I think that's it. So I'm going to stop sharing, and Pierre, it's over to you now.
Okay, good morning, everyone. So I'm going to share my screen. So normally it's okay.
Perfect.
Okay, so let's start. So good morning, everyone. I am Pierre Tuffigo, the CEO and the founder of a French company called ELWAVE. So we are developing electromagnetics detection and navigation based on a technology called the electric sense. So ELWAVE is acting on the subsea robotics market. This is a fast-growing market with historic activities, mainly the oil and gas, but also a new one, the marine renewable energy, subsea cables, defense and security, of course. So this is a large market with a strong growth. And this market faced two major issues. The first one, historically, this market for subsea inspection or maintenance uses some ROVs. They are very costly, up to 200 euros a day. This is the first issue. And the second issue is that these ROVs are inefficient in some quite complex environment. For example, when the waters are turbid, or for the survey of objects into the sediments. And this is due to detection sensor lacks, so mainly the camera and the sonar, which are used on ROV. And phase two, this need, and mainly phase two, with highly costly ROV operation costs. There is a strong need for the deployment of autonomous vehicles, so the AUVs, and also to improve security and to have some ROV which are more cost effective. And so to answer these needs, the main expectation from the ROV or the AUV manufacturers and operators are to have some innovative subsea perception technology to be able to fully deploy the AUVs and to have more cost-efficient ROVs. This is what we bring to the market. So our solution is a new active electromagnetic detection. It is based on technology called electric sense. ELWAVE is the first and only one company in the world to market this technology. It is issued from more than 10 years of academic research by a laboratory, French one. So basically, we generate an electromagnetic field around the vehicle on which we have installed our sensors. So we have a 360 degrees electric bubble, and any object which penetrates this bubble will perturbate the electromagnetic field. It will modify the resistivity in this bubble, and thanks to specific and dedicated algorithms, we are able to obtain an electric image of this environment. And so this electric image has some unique features. So it gives a real-time and 360 degrees perception of the environment. In this image, we can locate and characterize the object that have penetrated the bubble. So we characterize the size, the shape. Also, we characterize the type of material, if it is a metallic or non-metallic object which have penetrated the electric bubble. It is efficient in complex environment, so we are not perturbed by the turbidity of the water. It is efficient at short range, so mainly in cluttered environment, complex one, for example, in jackets of wind offshore. And it is also efficient for the detection into the sediments. So here you have some pictures of the current product. So our solution is a mix of hardware and software parts. There are three major characteristics of our system. First, it is very low energy consumption. so around 20 to 30 watt, very low size and weight, less than 30, 50, 40 centimeters, less than 5 kilograms. And we have no mechanical components, so our system is highly reliable. And this major characteristics allows us to integrate on any type and any size of ROV and AUV. And also it's a plug and play technology, so we are able to install or integrate our sensors on both new vehicles and in-service vehicles for their retrofit. So in terms of the market, so we address almost all subsea robotic markets, military one, for example, for the mine countermeasures or the anti-submarine warfare, and the civil one, civilian one, for the navigation of these vehicles, and for the cable and pipeline survey, especially the autonomous one with AUVs. For the monitoring of the infrastructure, etc., etc. So currently we have two product lines. The first one is directly based on the real-time 360 degrees detection. So it's a safety shield capability. So here on the drawing, it is depicted on the different field of view and perception given by the current sensors, the camera and the sonar, and the one given by our ELWAVE technology. And so we provide to the ROV and the AUV a full perception all around imaging of the vehicle. And this full perception will allow the ROV to efficient more safely and more efficiently in complex environment. And also it gives the AUV the full capability of navigation, complementary to the forward-looking sonar. Our sensors give the possibility, the capability to the AUVs to navigate safely, efficiently, very close to the infrastructure, in very shallow waters, etc., etc. So we are working currently with different companies in civilian and in defense market. So the second product line is the buried object detection and survey. So currently the main system are the magnetics one. Acoustics also are used complementary with the magnetics. And this system faced to some issues. They have some limited sensitivity. They are AV system. And regarding the magnetics, magnetic system cannot detect non-metallic objects. And our technology will detect metallic and non-metallic, conductive and insulating objects. So we have excellent sensitivity of detection. We provide a real-time survey, a real-time vision of the object into the sediments. And as we are very low burden, we provide the capability to AUVs to operate and to perform the autonomous survey of this buried object. So again, on this application, we work with civilian and defense projects and companies. Here on this slide, just an example. So we are a key enabling technology for the massive deployment of the AUVs. And if we have a look on the cost savings that the AUVs and thus that our technology can give to this market. For example, for a wind offshore farm, the use of AUV implies a €2 million cost saving per year. And if we look at the objective of the EU in terms of the total capacity with the wind offshore farm, so the EU plant capacity is 150 gigawatts. Our technology can allow some cost saving per year of 750 million euros. So our technology is a real deal breaker because it allows the massive and full deployment of ELWAVE for subsea robotics market. So this is the last slide. We are located in Nantes, so in France, on the Atlantic coast. We have currently 6 employees, 12 employees by the end of 2030. And during this webinar, we have 3 persons. So myself, Quentin Delplanque, which is the Chief Technical Officer, and Jean-Marie Lapassé, who is the Chief Commercial Officer. So we have complementary and large experience. And so we will be the 3 of us with you to answer your question right now and in the specific room after the presentation. Thank you.
Pierre, thank you very much. Why don't you go back to the slide that showed your complementariness? I think one more. No, go back 2 more, I guess. Sorry, go back to where it showed it against radar, or sorry, sonar and the vision.
Yeah.
I think that one is very interesting. So I forgot to say that we've asked each of the companies to speak for 10 minutes, and then we ask you that are listening to put your questions in chat. And then they will answer your questions. And Pierre did a great job presenting their story. When you'll have a chance to talk one-on-one with them, will be in the breakout session, which will start at 9 o'clock. We have about 8 minutes before the next presenting company. So please put your questions in chat. Maybe I'll ask, just to give you a little time to put your questions out. Pierre, if you think about a case study where you've been able to find something in the benthic layer, how far, I saw that you could go out like 30 meters, I think, looking forward through the water, but
yeah.
How deep have you been able to go, and what have you found? I mean, you showed a sign, a symbol of a bomb, and there's lots of those, unfortunately, around the coast of Europe. So I think the implication is that people are putting in new wind farms, and that was a stunning number that Ian said, where a quarter of the EZs might be eventually dedicated to wind farms. There's a lot of potential to find things before they put something in the ground. So can you talk about some example of something you found?
So yes, to answer the first question, so we can detect some object in the benthic areas up to 2 meters depth of burial. So this is what we do. And in terms of object that we can detect, so for example, regarding the wind offshore farm, so there is some survey before the installation. So and mainly in Europe on the North Sea, we have so many mines of the World War II, and some of these mines are buried, and some of these are made of aluminium body, which is not detectable. So which is a non-magnetic material and non-detectable with magnetic system. And so our system allows the detection of these specific mines. And this is a major issue for the operators to precisely locate and eventually destroy this mine. And we provide the capacity of detecting all kinds of UXO, and for example, these one that are not detectable with the classic system, I would say.
Thank you, Pierre. I see that you have 5 or 6 questions in chat, and then why don't you work through those, and then if you don't finish them,
yes,
then you can do them in your breakout room.
So I stopped the sharing of the screen because I don't see currently the question.
Well, the questions, if you go down to the bottom, go to chat. Right on the bottom, if you hover, you'll see a chat function, and then it should pop up.
Just give me a minute. Okay. Okay. So. Okay. So. Do you see any opportunity? So I have a question, private and non-private one. So I don't know. I will answer first the non-private one because I got some question from Melissa, but it was in private, so I don't know if it's really private or if it's public. And also another one from Alice there. So I'll start by Pete. Do you see any opportunities for this technology in the seafood industry? So yes, aquaculture is a market. Aquaculture infrastructure required some maintenance, inspection of the installation, and so of course they use some ROVs and not AUVs, but mainly ROVs in quite challenging environment, and this is a market for us as we can provide so this full capacity of this full perception of the environment. So this is a market for us. I have a question. What are your financial needs to bring your innovation to the market? So in terms of the market, so we commercialize our first product the very few next months. And then our budget funding needs for 2020 and 2021 is around 2 million euros. So we are currently raising some funds for this needs. But our first commercial products will be for the last quarter of 2020. So what I mean is the innovation is already partially on the market. So a question from Pedro Ribeiro. Amazing technology, thank you. What is the price range for sensors and software package for small AUV applications? Could you give some samples of the resulting images? So regarding the price range, I cannot say the price range here, but to give an evaluation, it's I don't know how to say. It's roughly I would say the price of the sonar. And as the price of sonar are very from non-imaging to imaging, so there's a large range of price. We are globally, I would say, in the same price range than the sonar. Some samples of the resulting images. Yes, we can give not here. I don't have with mine, but we will be able to provide you with some images. But on the presentation, you have seen some green bubbles, which are the perception bubble, and these are some so 360 and 3 dimensions one. So this is basically the images that we provide. We provide so real-time 3D images, and we provide some 2D images from the top or from the side of the vehicle. From Peter, could you use your technology for map out oil spills?
So Pierre, give a quick answer to this one, and then we'll move on to Carl.
Okay. So if I will understand the question, so the depth of barrier is 2 meters depth. Can we find the divers nearby boast? Yes, it could be possible. Yes, this is not a use case that we have thought about, but it's possible. Yes. From Stephen, can this be used to detect biological items, for example, living fishes of mammals, or recovery of human victims? So yes, it can be used for this. Just a very quick answer. Actually, the electric response given by a metallic object or a living object is different. So the living object have some specificities in the way they perturb the electromagnetic field. So we are able to detect them, of course, but also to characterize and to determine if the object that we have detected is a living one, biological one, I mean.
Pierre, we're going to need to stop and hand this off to Carl at this point. You've
Okay.
got a lot of questions, which is fabulous because it's great technology. We'll let you take those up in the breakout room afterwards.
Yes. Okay. So now I'm giving to Carl from Hefring Marine, and so Carl is going to present this technology to all of you. So it's a great one too, and so I hope that you will enjoy it. And thank you for your attention. And so for those who are interested, I will be with my colleagues to answer your question. So thank you.
All right, thanks very much, Pierre. Thanks for the introduction and a great presentation. So hello, everyone. My name is Carl Björnsson. I'm CEO of Hefring Marine. We are a company based in Reykjavik, Iceland. And I hope my slide jumps over in a second. Yeah, and we've developed a guidance and telematics system for vessels. So the best way probably to explain it is to compare it to similar solutions in automobiles. We have trackers in cars that monitor drivers' behavior for the purposes of improving driving safety. But the difference between the open water and the road is that the road remains fixed and doesn't move, and a speed limit is also fixed on the road. Whereas on the open water, it's of course no speed limit, and the environment is fully dynamic. So what our system does is what our system does is essentially monitor the movements of the vessel and translate those movements in the sea conditions into a safety speed limit for the operator. A fleet manager can then monitor the operation of the vessel in real time, location, performance of the operator, and receive automated trip reports at the end of each journey. To quickly explain the name, because it's a unique one, it comes from Norse mythology, from Ayin and Raun, the Nordic god and goddess of the sea. They had 9 daughters, and each of them were named for a different kind of wave, because we have a lot of different names for waves in Icelandic. And the 9th daughter was called Hefring, and Hefring means the rising wave, and therefore quite fitting for what we're doing. But what we're doing is essentially, with our current system, tackling the issue of boating accidents and the fact that 96% of them are caused by human error, mainly due to excessive speeding, operator inattention and experience, and operations in dangerous conditions. But what Hefring does is heighten the situational awareness of operators with guidance and impactful insights. And we want to realize the complete nature of vessel operations, and in the short and medium term, we're looking to advance the safety and performance of vessel operations with actionable and impactful insights. So we started off, my colleagues and I, in boat building, where we were designing a revolutionary type of hull and measuring the performance of that relative to other hull types. At the same time, there were a number of accidents in Iceland on like tourist type of vessels, the ones that take you out for whale watching and puffin watching. And we were seeing in our data that these accidents, whether they be spine fractures or broken teeth, were due to impacts as the boat slammed through the water. And we made a simple prototype to start off with, where we simply showed the operator the G-force experience, but G-force didn't really translate terribly well in an operational setting. So then eventually came our system, where we simply generate a speed limit. But in these studies, one particularly interesting one was where we approached a captain of a 12-meter vessel, taking out 12 passengers, and we put a sensor on board, obviously allowed by his fleet manager, but didn't tell the captain about it. And in that particular trip, we monitored impacts of around 4.6 G, which is significantly higher than the European standard, which is around 1 G in a workplace setting at a maximum. And then the next day, we did the exact same experiment, same captain, same boat, same number of tourists, and but told the operator about the sensor. And the difference was very dramatic. And so we realized that there's definitely something in this behavior monitoring. But with our solution now, what use cases we've gotten back from our users are that they are seeing this as a solution to enhance boat monitoring programs, to improve their operational transparency, improve operator situation awareness, build a stronger safety culture. And a good example of that is an operator, fleet manager for a whale watching company here in Iceland who approached us. We made him an offer for one system, but in fact he wanted 7 for all of his vessels because there was no reason and there was no way to build a stronger safety culture if it was just applied to one vessel. Improve efficiency in operation and in safety policies, optimize training of new operators, which is what the Search and Rescue Training Academy here in Iceland is now doing, using our system for. Preventing structural and equipment damage to the vessel, as the more efficiently you move through the water, the less slamming and your boat is experiences, and therefore less likely to be damaged. And the data from those trips can be then used for warranty claims, where both the builder and the boat's user suffer if they have no data, where it becomes just your word against mine. But we work with a number of, in particular, rescue organizations, such as the Icelandic Search and Rescue, the Norwegian Search and Rescue, Icelandic Coast Guard, insurance companies here in Iceland, and we are a member of the Port Excel Accelerator program in the Netherlands, in Rotterdam. Our initial target market is the rescue and tactical segment. We actually started off approaching the tourism boat segment because we saw the biggest pain points there, but we launched our product at exactly the same time as COVID happened. So we had to pivot a bit, but that's proven quite successful as the rescue sector actually sees the same issues as our initial target market. But we've also received other requests from different types of segments, such as unmanned surface vessels and owners and operators of larger vessels. This first product that we have now that we launched in March is a fully functioning solution, but it is something that we're more using for feedback and to develop our system further, where we are working with on pilot projects with partners for improvements to our current features and to build up new features that are more specific to their needs, while still following our roadmap of moving toward data and a software as a service model. Technical features in the improvement of our solution are focused on ML and AI prediction capabilities, connecting to other data sources on the vessel, other sensors and instruments, whether that be weather station or engine computer, and integrating with the vessel's display, for example, to avoid the need for an additional display. The system that we're working towards is a subscription tiered system with packages for different users, as well as a dedicated system model where it will look something like this. Today, we essentially have the advanced standard solution ready. And while we had intended on moving to a more sophisticated version, we decided to go and build a free app version of our system. Main reason for that is because in these travel restrictions, it's quite difficult to go and meet international partners and showcase and try out the system with them. So we decided to make a teaser of our system, a demo that can be easily downloaded without much commitment and tested, even though it's not the fully functioning system. But we want to expand on that as well, make a basic version with additional features for focus at the recreational market, while the advanced is more commercial, rescue, and tactical, with dedicated sensor and equipment provided, and then an enterprise solution for special purpose vessels such as autonomous or larger. So it's a large market, large number of vessels. We are focusing on the rescue segment at the moment, but see application in all these sectors. But within all of them, there's a growing need for new software and IoT technologies that are yet to be represented properly in these market sizes, and demand from safety and security in search and rescue for better navigation and monitoring. But Hefring Marine is well positioned to meet those needs with an innovative solution. In terms of the global UN goals, we fit quite well into a number of them, but we can take 2 here in particular to focus on. One being road accidents, which we don't technically target, but we target the second largest transportation related cause of injury, which is boating accidents. Likewise, we can improve the efficiency and safety for small-scale fisheries, which is something we intend on doing here in Iceland, where we have a lot of small-scale fisheries competing with the large industrial ones. We're a strong and capable team with a lot of experience from this industry and others. And right now, what we're doing is focusing on these strategic partner projects and building on more such projects in order to scope the requirements for commercially and technically for our SaaS platform. We're also seeking investors for a 1.5 to 2 million euro financing round. And following that, plan to expand our team for the development and execution of our SaaS platform. So that's Hefring Marine. Thank you very much for listening. And let me now open up the chat to check out.
Carl, first of all, fabulous presentation. You were right at 10 minutes. Thank you so much. You know, you really are a professional at this. I love the colors of your presentation. And even from Tuesday, we did the dry run to today, I think you've made it a little bit better. While the chat function is starting to work, let me ask you a couple of questions. One is, talk about the cost, but also talk about, if you can say it, the ROI, because when you talk to an insurance company, if they're going to give a discount to the companies, this more than, I would assume, this more than pays for the cost they're going to pay for you. So maybe you can talk about that. And the other thing I would ask you to talk about is whether this is OEM or aftermarket or both, and what you're really trying to accomplish.
All right, for the first question, if I talk a little bit about the ROI, we had an interesting conversation actually with the insurance company yesterday, who came to visit us, following a meeting they had with one of the largest tourist boat operators here in Iceland. And the tourist boat operator company had actually mentioned to them, now they're starting to mention to them our system, saying that this is something they want to implement on their boats, and now are starting to push the insurance company for discounts on their premiums. So the conversation has now sort of moved from our hands and over to those two parties engaging with one another. In terms of the ROI, speaking from the market that we know best, which is this, in terms of insurance, which is this Icelandic one here, but is also fairly comparable to most of Northwestern Europe, a single device on a boat will be paid up pretty much with one seat per day for about 10 days in a whale watching rib. So our current system that we're selling, we sell it at a fixed price to fixed 12-month subscription. It's around 2,300 euro. But a seat on one of these boats for a whale watching trip is around 200 euro. Now, an insurance claim is going to be significantly higher, a higher cost than that for both the insurer and the company. Not only financially, but also in terms of in terms of your reputation, your TripAdvisor ratings, or your reports that come out from the accidents that do occur. With the more commercial side, there's less like hard data to rely on, but we know if there's an incident on board, there's a direct cost related to that, but then there's indirect costs related to simply having that person either potentially going on disability or going through all the medical payments or medical costs that are associated with an injury, whether that be an acute injury or a chronic injury. So this, I think that answered your question there. I'm sorry, I got a little distracted because I started popping in the chat.
Well, the second question was, are you going to go to market kind of aftermarket, or are you going to try and talk to the manufacturers of ribs and other vessels? Or both, because one is a lot more difficult. The aftermarket is harder probably to service than getting into the vessels themselves as they're being built. Yeah,
so what we're doing right now is actually getting into the best vessels as they're being built. We're working with boat builders some of whom have actually integrated our system into their consoles, so that it sits right in front of the operator. So that's the approach we want to continue going for. And when we get further down the line of actually integrating into the displays, we essentially are a software company where our system can be integrated into those platforms. And that's how we want to move forward.
I'll let you turn to the chat now.
Yeah, so there's a question here from Oyvind. Have you validated that your SaaS revenue model is accepted in all market segments you are focusing on? Yes, we have. One issue, to be honest, that we run into, because we have this one standard system at the moment, is that there are very different price points in all of these different markets, which is one of the reasons as well where being a more feature-based SaaS model makes it easier to apply those features directly to the type of users that need them. Within the rescue industry, this price point is very much something they might expect, whereas a private boat owner might consider it to be a little high. So therefore, a simpler solution, which still uses the core data and technology with fewer features that a private boat owner might not need, is a way to segment our technology toward different users. So overall, yes, we've validated that it works quite well. Next question from David. Any plans to hook into autopilot to automatically lower speed based on conditions? That is something that we have considered, yeah. It's not something we want to do right now, not yet, but it is something that is definitely it's something that we have definitely considered and would further down the line want to add as a potential feature. Have you considered, from Colin here, have you considered a role for your system for predictive maintenance similar to onboard diagnostics that have become prevalent in the aerospace industry? That's a good question. And there was a slide that I took out of my presentation simply because it was too wordy and it would have taken too long. But it went through some of these features that we'll be developing for our next version of the product. One of them simply being predictive maintenance, both for the fleet manager side and on where fleet manager can guide an operator to follow certain parameters based on a specified use of the vessel in order to minimize future maintenance. With that as well, other features would be route guidance, get around the conditions where you don't want to be operating in, which goes hand in hand with your maintenance. How do you operate your vessel in the most efficient manner so that you are not putting it into a situation where it will likely need more maintenance? So yeah, it's definitely something we're looking into. Core focus of what we want to do, there's systems out there that produce a lot of raw data and then show you all that raw data in real time, but what do you do with all that raw data? We want to simplify that essentially and give you something actionable to actually work with, so you have KPIs more than raw data.
So Carl, we don't have any more questions right now in the chat. Hopefully one or two more come in. But let me ask you about the autonomous vessels. You kind of hung that out there, and I can understand very easily the savings in both bodily harm and the health costs, the pain that people go through, the reputation. That all makes perfect sense to me. U.S. Coast Guard might be interested in this for their people. So I can understand any manned vessel. Talk about the unmanned vessel side. Why would that be of interest? What can you do for them?
Yeah, so that was a segment we hadn't really considered until a builder of autonomous vessels approached us, because they had the issue of remotely operating their vessels and knowing how they should be operated based on the conditions they were in. They saw an opportunity in essentially using the guidance system that we have typically on board, putting that in the operator's console on shore, in order to give the operator direct input into what speed they should be going based on of the movements of the vessel itself. Their issue being they are relying on camera input mostly. They are largely stabilized so that you can actually use them, and that the downside of that is that you aren't able to interpret properly what kind of movements the vessel is actually going through itself. And also there's just the element of nobody being on board to feel the breeze or feel the wind or feel the movements of the vessel and then make an accurate judgment on how to operate it. So they would have more maintenance than they would have liked, and saw an immediate opportunity in using our system to just simply make it easier for the operator to run these vessels.
Isn't it wonderful how technology, you come up with one use and then you realize that other people see other opportunities for you. So congratulations. So with that, would you like to hand it off to Mark then?
Yeah, so thanks very much, everybody. So I'll hand it off to Mark Gunderson, CEO of Marine Advanced Robotics, to take you through the next presentation, the next company. Thank you.
You'll release your screen.
Yes.
All right, let me share the screen. Can everybody hear me?
Perfectly.
Great.
Everybody else is muted.
All right, does everybody see the main screen there?
Yes.
Okay, great. All right, well, thank you, Carl, and great presentation and really great technology. Good evening, everybody. Good afternoon, I should say, to some, and good morning to everybody else. My name is Mark Gunderson. I'm the CEO of Marine Advanced Robotics. We are an autonomous surface vehicle manufacturer and service provider. The acronym for autonomous surface vehicle is ASV, and you'll see and hear it quite a few times during the presentation. I'm going to try not to use too many other acronyms so I can avoid any confusion for folks that might not be as familiar with maritime robotics. So the case for maritime robotics is strong because it is extremely expensive to operate in the marine environment. The vessels you see pictured here cost between $15,000 and $200,000 a day to operate. Obviously, when we go to sea, we have to bring everything with us. When I say we, when humans go to sea, they have to bring everything with them, which obviously adds a lot of cost, and the fuel burn is extremely high. So we already established that operating traditional crewed vessels is expensive. That's depicted in this slide on the image on the left, which is for comparison purposes. We picked a given area and calculated that costs about $25,000 to survey it by traditional means. So we approach marine autonomy in two ways. The first is as a force multiplier, which is depicted by the image in the middle of the screen. And this is where we pair up our robots with existing manned assets. So you already have the manned asset out there. You already have that cost. But by teaming up our robots with it, it allows the unmanned team to collect a lot more data in the same amount of time for a marginal increase in the day rate, which translates into a much lower data acquisition cost. In this case, the addition of 6 WAM-Bs results in an 80% reduction in cost. The second way we approach marine autonomy, marine autonomy is the image on the right. And this is where the WAM-B goes out and does the survey completely on its own. And with this method, costs can be reduced by as much as 94%.
Mark, for whatever reason, the audio has gone really quiet. We hear you, but if you could try and get closer to the microphone. I don't know what's happening. It's an audio channel thing, I think.
Okay, is that better?
Somewhat better. Just, keep going. It seems to me that it's not your microphone. It's probably something else.
Okay, can you guys still hear me? I just saw that the host muted me.
Yeah, we hear you, but it's just more muted. So just keep going.
Okay. So our technology is called WAM-V, which stands for Wave Adaptive Modular Vessel. We treat waves like bumps and absorb that energy with our patented technology. The result is a more stable platform that can operate in rougher sea conditions than a similar sized vessel. In fact, we punch above our weights. A good example of that is on a project we did where our 20-foot variant delivered multi-beam sonar data that was superior to 2 other manned vessels on the project that were actually twice as large. WAM-Vs are also modular, which means they can be quickly reconfigured for different applications. They can be taken apart quickly and boxed for shipment or reassembled on a beach or riverbank to be launched. The WAM-V technology is scalable. To date, we've built WAM-Vs in sizes ranging from 2.5 meters to 30 meters, and we've also worked on a design for a 40-meter variant for a potential customer. The stability of the WAM-V and catamaran configuration make it an ideal sensor platform. We have launched unmanned aerial vehicles and remotely operated underwater vehicles from the WAM-V with great success, and we're currently working on autonomous launch and recovery for autonomous underwater vehicles. Our control system and mission planning tools are extremely easy to use and understand, and we've built a lot of nice application-specific features over the years that our end users really appreciate for their missions. We also hold a line to within a meter, which is very beneficial for applications like marine survey. Think you're going from one waypoint to the other. That's the line you want to follow, and obviously, if you're collecting data, you don't want to very far from that line. The WAM-V8 is our smallest platform at 8 feet long. This variant actually came about because one of our clients was dissatisfied with the performance of the vessel they had because it couldn't collect good sonar data when the wind and waves kick up. So even in inshore and nearshore waterways, obviously wind kicks up and waves get big. And for some platforms, the quality of the data just goes down a lot. That's not the case for our technology because of the suspension system and how we absorb that wave energy. The image on the top left is from training we did for that customer, and they said that they wouldn't have been able to operate in those conditions with the platform they had, but with the WAM-V8, the data they were getting back was beautiful. The WAM-V8 is also the only ASV in the market at this size that you can take on a plane as checked baggage. The WAM-V16 is the next size in the product line. This one's 16 feet long. Has electric outboards and batteries, and it's really perfect for day operations or for sensitive environments where you can't have gas-powered systems. Like all WAM-Vs, it can be disassembled for shipment, storage, or to be reassembled on a beach. It also, and that you kind of see that in the bottom right there. It also has the payload capacity for launching and recovering unmanned aerial and subsurface assets. So when you jump up to the WAM-V22, you get into multi-day endurance and higher payload capacities. This one is where we start bringing in gas-powered propulsion systems as an alternative. So again, you can go electric or batteries, or you can also go to gas, and that's where you start getting that multi-day endurance. The higher horsepower and the bigger footprint make it ideal for high energy environments like high current rivers and open ocean conditions. In addition to selling WAM-Vs, we also offer robotics as a service. Basically think robot for hire. A good example of this capability is a project where we brought 2 WAM-Vs to work off a manned survey vessel and delivered the data to the customer. Our markets include the maritime defense and marine survey markets. We actually got our first real traction in the defense market. And the development work we do in that market has translated really nicely into the marine survey work we do, and we feel this will also be true in other markets. Traction to date, we have over 70 WAM-Vs operating in 10 countries. We have distributors in 3 countries outside the United States, and we've really been blessed with a lot of really great customers and partners. Which you'll see as a partial list of right there at the bottom of the slide. Okay, so I'm going to quickly go through just a few case studies to give you an idea of what our customers are doing. USRV dive team was trained on using the WAM-V8 for pier and piling inspections. Portability of this vehicle allows them to quickly mobilize it and take it and respond to events that require immediate attention. Those obviously can include natural disasters, man-made disasters, and some of the other applications they have and mission sets they have. We've done several integrations with unmanned aerial and unmanned underwater vehicle manufacturers, and we definitely see a lot of potential in this capability. And we also had several industry firsts on this project where we operated 2 WAM-Vs with a crewed survey vessel. The WAM-Vs autonomously tracked and trailed the crewed vessel at different offsets, and the sonar data from all the multi-beam sonars was brought into one instance of the sonar acquisition system, which you see there in the bottom, the middle of the middle image on the bottom row. This was the first time this was done for hydrographic survey, and it allowed the hydrographer to see all the data in real time and make informed decisions about sonar overlap adjustments. We meet several UN Sustainable Development Goals, and we believe in them. You know, our One Ocean is really critical to our future, and we really support the work being done here. Here are the specs for the 3 WAM-Vs I mentioned earlier. I won't go into them in detail, but wanted to include them in the recording so people could pause here if they want more details. You can also find these specs on our website. Our next steps are to continue to broaden our distribution channels in the markets we are targeting, to form strategic partnerships and bring in investments so we can grow more quickly into the opportunities currently in front of us. All right, thank you everybody for your attention, and I look forward to your questions.
Thank you, Mark, great job. You might want to talk just for a second while the questions are coming in. I see one is up there now, but give people a moment to put some more questions into chat. I know that ONR, Office of Naval Research, chose your vessel some years ago as a common platform to test different sensors. It might be useful to just talk about that. Why were you chosen? How is it used? How many years have you been involved with that? Because I think it you know, really helps validate the unique technology you have.
ONR saw the vessel as like Michael said, a great platform for doing a lot of different things. The stability of the vessel was a big factor in that, and then also this catamaran configuration that really gives you know, unique access to the water, right? From the center platform, you can quickly and easily deploy things without slinging them over the side or off the stern. And then also the ability of our vessel to quickly be disassembled and shipped. You can get it quickly and easily around the world. And then you can also, you know, quickly outfit it with other sensors and other equipment. So I think all those things came together to really attract them into platform, and then that work kind of expanded out from there to NSWC, NOCAD, and other groups.
Why don't you pivot over to the questions?
Okay. I just want to make sure I started the right one. Okay, so this is, I think this one's related to the memorandum the president signed. So this is definitely, so for those that don't know, there's been a focus on mapping the EEZ of the United States. That's the area out to 200 nautical miles. I think at this point, well, we might, I mean, we're at a very low percentage. I think there's the calculation was it would take 100 ship years to actually map the area that needs to be mapped with modern technology. So this is definitely something we're targeting. We think the force multiplier is a great way to do it at a very cost-effective way. So we are talking with folks about doing that. And the next question is related to that as well as with Seabed 2030. So I'd say the same answer to that. Force multiplier role, is that akin to UAV drones as wingman for F-35s? Yeah, so really it comes down, so you, again, I mean, that's a great way to think about it. You basically set the offsets from we'll call it the lead vessel. The lead vessel doesn't necessarily have to be the crewed vessel. It could be any one of the vessels in the network. So a WAM-V could take point, and then all the other vessels could operate at set distances from that. And those can all be adjusted in real time, because obviously as you change bottom depth, distance change on your offsets, so you can adjust that all in real time to make sure you're getting cover, you know, the coverage you need, and not having any holidays, any gaps in your data. The autopilot we're using is our own, developed in-house. And then we also play nicely with the different, for those of you who are hydrographers, we play nicely with the different acquisition software, the different company acquisition software. So that's an easy thing to go back and forth between the acquisition software and the WAM-V autopilot. When a given customer is deciding on an ASV, what is the most difficult part of that process for them, in your view? I think a big one is obviously, well, maybe not so obviously, but ASVs, autonomous surface vehicles in general, are an expensive asset, and so it's a big purchase for a lot of companies. And so I think the most difficult part is really having that opportunity to try it out first, or know somebody that's used one, that sort of thing. So for a lot of us, for a lot of the things we do, a great entry point is the robotics as a service. Allows somebody to bring it on, not as a CapEx, but bring it on a project and see it, and then make a decision from there. And that's actually led to sales for us. I think that, yeah, that's the last one. I hope I didn't miss any.
Mark, oh, I see somebody else popped up.
What is the propulsion for the WAM-V 8 proper jets? So that's a good question. One of the other things about the WAM-V is within this modularity is the ability to switch out what we call the engine pod, which is the aft section. So almost for all of the WAM-Vs, you can switch between different propulsion systems. So say you want a larger diameter, lower RPM prop for higher efficiency, you could have a set of engine pods for that. But you also want a jet propulsion option, so you can do the super shallow water. So you could also have an engine pod set for that. For the WAM-V 8, we currently offer thrusters, and then we're also adding a jet to the lineup to give again that versatility in application. We probably aren't going to go to any kind of bigger prop, because a lot of the work that folks want to do or seem to want to do with it include shallow areas, and so we don't really want much to extend down.
Mark, why don't you talk a little bit about how you've integrated unmanned aerial vehicles and unmanned underwater vehicles in your platform, because that makes you unique at that air-water interface, to be talking real time with satellite or Wi-Fi or whatever it is, but also having things in the sky and things underwater.
Yeah. So the work we've done there to date has been defense related. So we've done a demonstration in NavBase San Diego, where we brought in Planck Aerosystems UAV, unmanned aerial vehicle, and then also Teledyne Seabotics, their ROV, remotely operated vehicle, so tethered underwater vehicle. And that particular application was for maritime security. So think, the different Navy bases being able to identify a potential threat and then be able to investigate, from the air, from the surface, and below the surface. So in case that, somebody drops something overboard, you want to be able to quickly go in and find it and see what it is. And then from there, we obviously see the potential on the commercial side, right? Where you start talking about marine infrastructure inspections, think bridges, think ports and harbors, you start offshore wind. I mean, there are a lot of different applications, oil platforms. There are a lot of different applications where you want to be able to bring in an asset, an underwater or an aerial asset with a vehicle like the WAM-V that doesn't, it's not this big offshore supply vessel or something like that you don't want to get very close to your assets. You got something like the WAM-V with inflatable hulls, very lightweight, won't do damage if it runs into something. So I think that's very attractive as well.
Mark, I think you've brought us right up to the 9 o'clock hour. So I think at this point we will break and ask everybody to mark down the information. You should have received, all of you, an invitation, an email from Shara Narsapur, which gives you the breakout sessions. It's just easier for us to end this session and then for you to go off into the breakout rooms. One of the things we did in order to make this a manageable time is there's some number of people that want to hear the three companies present that aren't necessarily interested in going off to breakout room. But our hope is that those that will go to the breakout room are those that are particularly interested with those companies, whether that's 5 or 20. So we are going to stop this session, and you should have all the information. I see it's also up on the screen again. And Shara has also put it in the chat feature if you need to download it. So please, thank me. Join me in thanking the three people. All of you are on mute, so I'll clap for all of us for the three presenters. Thank you very much. Great presentation. We're going to cancel, we're going to stop this particular webinar, and please go into one of the breakout sessions to learn any more about one of the three companies. Thanks very much for participating today. Bye-bye.